Hey everybody. All right, we're going to finish 3.4 now. We have been talking about the position function and the velocity function and acceleration function, which are kind of derivatives of each other. If you take the derivative of position, you get velocity. If you take the derivative of velocity, you get acceleration. So now we're going to look at a different way of using derivatives in the real world. Derivatives are used to predict change, you know that, and so economists use derivatives a lot to predict profit or cost or revenue. Probably they use it for other things. These are the three we're going to talk about: profit, cost, and revenue. Okay, so here's kind of how it works. Let's assume that this axis right here, the x-axis, this is number of items produced, okay? Number of items. And the y right here is the money, the profit that is created with each item. So right here, this point right here, so this is a profit function, Okay. Now, this cost right here, or this number of items, excuse me, is, we're just going to call it X. Now, the profit at that point would be P of X. I think you would agree with that. We're just filling in what it tells us to do right here. Label the initial point P, comma, or X, comma, P of X. Now, if we increased X by 1, what is the actual change in profit? Well, if we increase X by 1, let's call this amount right here 1, so this point right here is X plus 1, then what is our actual change in profit? Well, our actual change in profit is over here. This is going to be P of X plus 1. Our actual change in profit is this much right there, from this dot down to there. That's our actual change in profit. But the question is, because it is difficult often to find points on curves, the question is, if we draw a tangent line right here, it's supposed to be a straight line, if we draw a tangent line right there, can we use that tangent line to predict an approximate change in the profit? Let me try to redraw that a little better. What if I actually use a line? There, that looks better. Okay. So there's my tangent line. The question is, can I use that tangent line to predict this increase in profit from here, or at this point here? Instead of being right here, we would call it all the way up here. Well, as long as you don't move too far away, it's actually pretty accurate. If you move way far away and your curve is moving one way and your line's moving the other, then they'll be very different. But when they're pretty close, and we're going to call increasing by 1 pretty close, if they're pretty close, then it's a good estimation. And using the tangent line is a much easier method to find the marginal revenue or marginal cost or marginal profit. Think about marginal as change, okay? The change between making X items or the change between making X plus 1 items. Okay, so let's see, we're here now. Now consider the tangent line. The slope of the tangent line is given by, well, this line right here. What is the slope of this line given by? It's given by the change in Y over the change in X, just like any slope of the line. And the slope of a line is given by, well, we've talked about this. What is it given by? It's given by the derivative, which in this case, the derivative is going to be P prime of X. Now, if we consider that X only changed by 1, then the slope of the tangent line equals the change in Y. Why? Because this right here is 1. We would have change in Y over the change in x, which is just simply 1, because we're letting it be 1. So therefore, the change in y over 1 equals p prime of x. That's where this comes from, right here. The slope of the tangent line equals the change in y. So p prime of x minus delta y. That should be equals delta y. I don't know why I said that, because it's wrong. P prime of x equals delta y. Make sure that's fixed on yours. It looks good on my worksheet, but not on this PowerPoint. Okay, this is the underlying principle in the following definitions. If x changes by 1 unit, which we are letting it, then the change in y is approximately the value of the derivative at the original x. Let's do a problem, or let's look at this first and then we'll do a problem. Okay, so here are the things we need to know. Marginal cost is given by the marginal cost at x given by c prime of x is the approximate cost of the x plus 1st, so x plus first, I suppose, item. Marginal revenue at x given by r prime of x is the approximate revenue generated by x plus 1, and profit is generated by x plus 1 on the profit function. So let's do a problem. I think it's going to make a little more sense, hopefully, if we do a problem. Suppose that the daily cost in dollars of producing X radios is C of X equals all this. And there are currently 40 radios produced daily. So this is the daily cost making this many radios. What is the current daily cost? Well, to get current cost using this function, all we have to do is plug in the number made on a daily basis into the cost function, and it will give us that. So we would simply do C at 40, and instead of showing you all that, I'm just going to tell you the answer. It is 2,268. You can use your calculator and plug it in right here and tell me if I'm right or wrong. Now the next question, what would the actual additional daily cost of increasing production to 41 radios daily? What would the actual daily cost of increasing production to 41 radios daily? How would we do that? Well, actual cost means we need to not estimate. We're actually on the function here. So how are we going to do that? Well, we're just going to plug in. We don't always have this easy function here, but right now we do. So an actual daily cost is just going to be the cost to produce 41 minus the cost to produce 40. And that is going to give us $59.94. Okay, what is the marginal cost? Marginal cost, what is marginal cost? Is the approximate cost to produce this next item. We know how much it costs to produce 40. Now we're going to estimate how much it costs to produce 41. That one additional one is what we're really calculating here. Okay, so how do we do that? Well, anytime you see marginal with these problems, you need to think derivative, because that is giving us the estimated change from the original amount, which in this case is 40, to the new estimated amount, which in this case is 41. All right, so we need to take the derivative. So we're going to have C prime of x is equal to, well, after you plug it, you take the derivative of this, okay, you get 0.006x squared plus 0.02x plus 42, and then you plug in, I guess I could write that down. And then you plug in 40. Why do you just plug in 40? Because we need to find the slope of the line at the original point. We need to find the change at the original point, and that will tell us how much it's going to be to produce one more. So we are going to have, when we plug all that in, we're going to have $59.60. So you see how close that is up here to the original. Now we don't always have this nice pretty function. Think about it that way. Sometimes, or we don't have a nice pretty graph. Sometimes we're given one or the other. That's why we need to use derivatives here. That's why they're helpful. Okay, let's see. Suppose the cost of producing X units is given by C of X equals 4X squared plus 300 over X. What is the marginal cost of producing the 11th unit? Well, same thing. When you see marginal cost, you think derivative at the current level. That's what you need to think, because that gives you the change at the current level, which will give you an approximation of adding one more. All right, so let's see, what are we going to have? Let me rewrite the equation. C of X equals 4X squared plus 300x to the negative 1. I'm just bringing that x up there. Now let's take the derivative of that. We're going to have C prime of x equals 8x minus 300x to the negative 2. Now when we plug in the original value, what was the original value? It was 10, because this time we're producing 11, so you always say your original value is 1 less than that. So our original value is 10, plug that in, and you end up with $77. So what does that mean? It means that it will cost $77 to produce the 11th unit. So the small marginal change in cost is $77. All right, I hope this makes a little bit of sense. Economics is not my favorite or best subject by any means, but we need to understand how derivatives and calculus are sometimes used in the field. All right, so we'll talk about questions tomorrow. Bye.